Hi, Assalamualaikum. My name is Rp-Hplc. My student ID is 2020610918.
Hi and Assalamualaikum. My name is Muhammad Naib bin Batu Zaman. My student ID is 2020626058.
Assalamualaikum and hi, my name is Nurul Ainat Bizana binti Rasman and my student ID is 2020815522. For our case study, the paperwork that we choose is a validate river phase Hplc method for the estimation of quantipede involved and pharmaceutical formulation. Based on the literature survey, it shows that there are several methods for the estimation of quantipede, but the most suitable method is the river phase Hplc method. The overview of this paperwork shows that the quantipede is chromatographed on a reverse phase C-active water columns, where the mobile phase consists of phosphate buffer and acetonitrate. The flow rate of this mobile phase was 0.8 ml per minute with the detection at 291 nanometer. What is quantipede fumarate? Quantipede fumarate is a generic prescription of neuroleptic, which also called as antipsychotic. This quantipede fumarate also classified as a second generation antipsychotic, and it also known as a major tranquilizer that reduce schizophrenia symptoms such as hallucination and delusion, and it also helped to stabilize mania in bipolar patients. The exact mechanism of quantipede fumarate acting is antipsychotic is unknown, but it might work by balancing two chemicals, which are dopamine and serotonin, where both of these responsible for transmitting nerve signal in the brain. This quantipede fumarate will slow down the brain, reduce disorganized brain activity, and at the same time relieve negative symptoms such as depression and inability to focus. So what is Hplc? Hplc is abbreviation for High Performance Liquid Chromatography, where chromatography is a technique for separation, chromatogram is the result of chromatography, and chromatograph is the instrument used to conduct chromatography. This Hplc, also known as high pressure liquid chromatography, it is the most popular technique in pharmaceutical preparation and measurements due to its simplicity and versatility. Hplc also represents a technique which includes complete procedure, and this procedure is performed by the aid of specific device which called as Hplc system or Hplc device. Only compounds dissolved in solvent can be analyzed with Hplc. Hplc separates compounds dissolved in a liquid sample and allows qualitative and quantitative analysis of what components and how much of each compounds are contained in the sample. The mobile phase is delivered to a separation column, otherwise known as the stationary phase, and then to the detector at a stable flow rate controlled by the solvent delivery pump. A certain amount of sample is injected into the column and the compounds contained in the sample are separated. These compounds are detected by a detector downstream of the column, and each compound is identified and quantified. As Hplc can separate the compounds, each compound also can be easily detected by Hplc due to the difference of each compound speed through the column. There are two phases for Hplc that we need to know, which are the mobile phase and also the stationary phase. The mobile phase in Hplc is the liquid that dissolves the target compound, while the stationary phase is the part of column that interacts with the target compound. In the column, the stronger the affinity between the component and the mobile phase, the faster the component moves through the column along with the mobile phase. On the other hand, the stronger the affinity with the stationary phase, the slower it moves through the column. For this specific case study, we use reverse phase chromatography for quantipede fumarate, where the reverse of the above applies on the stationary phase as a very nonpolar, while the mobile phase as a relatively polar. In this kind of situation, the nonpolar compounds are later than polar compounds. Therefore, the elution speed in the columns depends on the affinity between the compound and the stationary phase. The validation of developed method was carried out for specificity, linearity, precision, accuracy, robustness, limit of detection, and limit of quantitation. Specificity was established by focus on preparing a quantific standard at 0.5% level of test concentration, where it then injected 5 times into Hplc system as per the test procedure. Second, as for linearity, it was evaluated by linear regression analysis using the least square method. Third, for precision, in this case study, it was determined in terms of intraday and interday precision variation, where it calculates in terms of coefficient of variation obtained by multiplying the ratio of standard deviation to mean with 100. Next, the prediction of limit of detection and limit of quantitation is based on the parameters of standard error of estimate and slope calculated from the linearity of the response data of Quatiapine. 5. The robustness was checked through the change in the flow rate to 0.7 and 0.9 ml per minute, and the temperature also changed to 20 degrees Celsius and 30 degrees Celsius. Last but not least, the accuracy of the Hplc method was assessed by adding known amount of drug solution to a drug solution of known concentration and subjecting the sample to the proposed Hplc method.
Okay, now we will move to the methodology. For the chemical the first one is potassium dihydrogen phosphate, the second one is orthophosphoric acid, and the next is acetonitril and Quatiapine Fumarate, and also Quatiapine tablets. The separation was carried out on Hplc system with 2695 Henry Hplc LC pump with a 2487 UV visible, a dual absorbent detector. It's using the Empower software and Rp-Hplc 18 column. The mobile phase consisting of phosphate buffer, which is pH 3 adjusted with orthophosphoric acid and acetonitril. The mobile phase consisting of phosphate buffer, which is pH 3 adjusted with orthophosphoric acid, and the acetonitril was filtered through 0.5 micromembrane filter before use. This is the gas and were pumped from the solvent reservoir in the ratio of 40/60, and then it was pumped into the column at a flow rate of 0.5 milliliter per minute. The detection was monitored at 291 nanometer and the runtime was 4 minutes. The volume of injection loop was 10 microliter. Before the injection of the drug solution, the column was equilibrated for at least 30 minutes with the mobile phase flowing through the system. The column and the Hplc system were kept in ambient temperature. Sample preparation. The stock solution of Quatiapine was prepared by dissolving 100 mg of Quatiapine in 100 ml standard volumetric flask that contained of 25 ml of mobile phase. Then the solution was sonicated for 20 minutes. Then it was made up to the mark with mobile phase to get the concentration of 1000 microgram per milliliter. The subsequent dilution of the solution was made with mobile phase to get the concentration of 20 until 120 microgram per milliliter. The standard solution prepared as before were injected into the 10 microliter loop and the chromatograph was recorded. The calibration curve was constructed by plotting concentration versus peak area ratio. The amount of Quatiapine present in sample was calculated through the standard calibration curve. The linearity experiment was carried out in triplicate to ascertain accuracy and precision of the method. The peak area ratio of the drug versus concentration were found to be linear. Limit of detection (LOD) and limit of quantitation (LOQ) for Quatiapine were predicted based on the parameter of standard error of estimate and slope. This is calculated from linearity of the response data of Quatiapine. Two commercial brands of tablets were chosen for testing suitability of the proposed method to estimate the quatiapine in pharmaceutical formulation.
Next, we go to the result and discussion. By applying the method, the runtime of the method was set at 4 minutes and quatiapine appeared on the typical chromatogram at 2.929 minutes, which indicates a good baseline. Next, when the same drug solution was injected 5 times, the retention time of the drug was same. The impact of this, the linearity range was observed in concentration range of 20 to 120 microgram per milliliter. Based on this result, we can plot that the standard calibration curve, and then we found that the regression equation of quatiapine concentration over its peak is y equal to 8382.87 plus 6008.88x, and the R is 0.999, where pi is the peak area ratio and x is the concentration of quatiapine microgram per milliliter. The precision of proposed Hplc method was also validated for intraday and interday variation. According to Table 3 System Suitability Parameters, the drug's peak area's coefficient of variation for 5 replicate injection was discovered to be less than 1%, and then the tailing factor was discovered to be 1.19. The peak that we discovered is intended to be in good shape. Next, it was discovered that there were 3,695 theoretical plates, indicating that the column was performing effectively. The sensitivity approach is indicated. It was discovered that the limits of detection and the quantitation were 0.75 microgram milliliter and 0.2 microgram per milliliter. After that, several phosphate mixtures, including those involving buffer and acetonitrile, were investigated in order to improve the chromatography conditions. The peak and resolution has an excellent shape due to use of phosphate buffer and acetonitrile in ratio 40 and 60 volume over volume ratio. Lastly, based on the table 5, the accuracy was expressed in terms of recovery and calculated by multiplying the ratio of measured drug concentration to the expected drug concentration with 50 so as to give the percentage recovery. The fact, the quatiapine has a high percentage of recovery, which is 98.43 to 99.47. So that means it is quite accurate. No interfering peaks were detected in chromatogram using this method.
In a conclusion, the proposed Hplc method was found to be simple, rapid, sensitive, precise and accurate for the estimation of quantipine in pharmaceutical formulation. Hence, this method can easily and conveniently adopt for routine quality control analysis of quantipine in bulk and its pharmaceutical formulations. Why reverse-phase Hplc is being used for Quatiapine Fumarate? There are several reasons for this situation. First of all, it is more easier to use than normal phase. Second, reverse phase has hydrophobic stationary phase, which can be applied to a wide range of molecules, so it works well in retention time for most of the organic analytes. Third, reverse phase has more options for the chromatographer. It also allows precise control of variables such as organic solvent type, concentration, and pH. Last, reverse-phase Hplc method is very simple, rapid, sensitive, accurate, and precise for the estimation of quantipine in bulk and tablet doses in pump.
Thank you for watching.